all we need to have to get started with is the data set. Remember, we started from a CSV data set, but there was some missing value, some duplications. So we performed some tasks to get it somehow more clean, and eventually we arrived at a somehow more clean version of the CSV file, but it's not totally problem-free. Right? So we're going to start from here. And before we dive into things like pandas and other Python codes, I do want to clarify one thing about how to load CSV data. So what we did last time was simply to right-click on our on the link, including the notebook, and copy the link, and then this link can be fed into the pandas read CSV function, right? However, this time, just a very quick note, right? First of all, this CSV file we're going to use is included on my GitHub repository. Right? You won't have it directly, I guess, on your repository unless you also uploaded the same file. But then let me quickly show you. So this file name is called Players Clean CSV. So if you click on it, you'll be able to see the content of this CSV file. And in the address bar, you can see this link, right? So this link that points you to the location on my GitHub repository for this CSV file. But if you directly copy this link and try to use pandas.readCSV, it won't work, right? Because this is the page where additional elements were included to make the whole CSV file kind of nicely visualized, right? So it's not just the plain CSV file, it included other HTML elements. So if you directly copy this link, it won't work. Instead, if you have a file, like CSV file, on GitHub, you want to use it in Python, generally you want to look at this page, and there is one button, which is called raw. Click on raw, and that will give you the raw CSV file, right? And then once you can see this raw CSV file, then you can go to the address bar and copy the link. This is the link where you can feed into your pandas .readCSV function. Okay, so that's the first note. And the second note is that today actually let's try a slightly different way. Okay, so because not always we have the CSV file on a remote repository. Sometimes we have to deal with data files from our local computer. So one thing we can do is that if you look at this bar on the left and go to the last icon, which looks like a folder, right? So it's the files icon. Click on it. And then you will see this panel here. This is really, the working directory on the remote computer. Remember, we're using Colab, which is somehow a virtual computer hosted by Google. So this is the working directory, right? If you are using your own computer, imagine that this is the same directory where you have kept your Jupyter Notebook file. But for Colab, the Jupyter Notebook file is actually in your Google Drive, but the idea is the same. So this is where you can see what's in your working directory. Okay. Now, of course, this is temporary, right? So whatever you put there, next time you got disconnected and connect again, everything will be gone because Google will clean up everything you put there. It's not supposed to be a permanent storage space. What you can do is that you can look at this window and look for this icon. Again, the icon of a folder, but you can see there's the Google Drive icon. So what you can do is that click on Google Drive and then confirm that you want to connect to Google Drive and just wait until the mounting of the Google Drive is finished. Right? Remember, we have to log into the Colab using your Google account, so that directly connects you to your Google Drive. Now, here is actually my Google Drive. I can quickly show you my Google Drive. very simple, just the 3 folders here, right? So I put the materials, some materials we are going to use in this course, in this folder 0712, including the CSV file we're going to use today. We start from players underscore cleaned. And then let's go back to Colab, okay? And after mounting Google Drive, as you can see, there's one more folder showing up. This is exactly your Google Drive content, right? So click on the small triangle on the left to collapse this item, right? You can see that this drive folder containing my drive, and under my drive is where you have the files in your Google Drive. And then let's click on this folder. It contains 2 data files. And today we're going to use the players clean .csv file, right? So this time what we can do is that let me click on the 3 dots to the right of this file. And then there's options that says copy path, right? So this is going to be giving you the path that directs you to the location of the file in this working directory that contains the content of your Google Drive. Right? And then what we can do is that, let's go back to the code cell. Right? What we can do is that, first of all, we need to import pandas as PD. Okay, that's because we are going to use the pandas library to load the CSV file. Right? Now we're going to do df equal to pd.read underscore CSV, and then I'm going to include the path to the CSV file. Before we have been using GitHub, now let's use Google Drive, which has been mounted to the local working directory of the virtual computer where you're using Colab from, right? So remember, I just located that file in the working directory, and I'll copy the path. So I only need to paste it here. Now, this is the file path, right? So it's under the content directory, which is the default working directory for Colab. And if you are using your local computer, replace it with the directory that contains your local Jupyter notebook you want to work on, right? And then drive, my drive, 0712 is, those are the nested structure of the folders that contain this player underscore clean CSV. But of course, if you just directly copy what I have here, on your end, it won't work because it's in my Google Drive, which is sort of private, right? So if you want to, for now, if you want to have this command to go through, either you do the same thing to mount the Google Drive, and after mounting it, create a folder, to contain the CSV files you want to be stored. And then one thing you can do is that you can actually, again, to the right of the folder, I think you can click on the 3 dots and click on upload to upload the CSV file, right? So that's one strategy. Or if you want your code to get through, instead of this path on my Google Drive, you can do the same thing as before, which is to find the link to the player underscore clean CSV. That is, the GitHub link, right? So just right click and copy link and throw it into the pd.read CSV file, right? And this is just to demonstrate, I guess, a simple task, but somehow important. So not always we want to do things from a GitHub repository, right? So let me do it again because we do want to quickly visualize this data frame loaded from the CSV file, right? Now, this is our starting point today, and as you can see, there's no missing value, there's no literal duplication, right? But as we mentioned last time, we still have some problems. For example, looking at the first 2 records, Diego Alvarez in the first row. In the second row, D. Alvarez, likely they are the same person, right? And then record number 4 and 5, Maria Costa, likely the second row 5, right? So it's likely to be a typo. So they are likely pointing to the same player. So how can we determine which rows are actually duplications caused by different formats or things like typos, right? So this is the task we're going to figure out today. And let's start with something relatively simple. What we're going to do is something called fuzzy matching. So we just compare two strings, for example, two names, right? And then, example, Maria Costa and versus Maria Costa, but then the second name has 0 instead of O, so that may be a typo. So how do we determine if they are duplicates? What do you think? I mean, intuitively we have the idea, right? They're similar, but how can we tell they're similar? We need to do some kind of matching of the two different strings to decide how similar they are, right? If you consider the two names to be very similar, maybe duplicates, right? If they are somehow similar but not that close, well, just to be on the more cautious side, maybe we don't label them as duplicates, okay? So to do fuzzy matching, which is simply to compare two strings to see how similar they are, we're going to use some library called RapidFuzz to do the fuzzy matching. So let's move on to use it. But before we use it, I mean, for Colab or things like Anaconda, we typically have some default libraries installed automatically, but then this RapidFuzz library is usually not directly included, so we have to install it, right? So what we can do is that we use this command that starts with an exclamation mark, which is a bash command instead of Python command. So pip install RapidFuzz, the name of library, right? So we only need to do it once, and then we're good for the rest of the time we deal with this notebook in today's class. So we just need to wait until it is installed. Sometimes it fails, you have to figure out why, but thankfully today it was okay. It says that we have successfully installed this RapidFuzz library. Now, after installing it, I'm gonna put the hash sign in front of this command so it's commented out. Next time you run this code cell, this command won't be executed again, okay? Now, after we actually install the library, let's import it. So this time we're not gonna use everything in this library. Instead, we just need to have a submodule of this library called fuzz. So what we can do is that we can do from this library RapidFuzz, import the fuzz module, and the fuzz module will contain the function we're going to use, okay? So this is the importing command. And then let's compare two strings. Let's define string 1. Let's say it's Maria Costa. Okay. And then string 2 is the name Maria Costa again, but with a typo, C0STA. Okay. So we have the two strings defined, assigned to the variable string 1, string 2. Now, we're going to do this fuzz. That's the submodule we imported, right? .w ratio. So I'm going to explain the meaning of this function w ratio again. But for now, very simple, very intuitively, it's just a function that allows us to compare two strings. So we're going to compare two strings, string 1 and string 2, defined by the previous command, right? And then we use those two strings as the input argument for that function. And we're basically done. So let's click on this running, play icon for the cell to run the command, and we can see that things are completed. Okay? So what this W ratio gives us is a score to determine how similar those two strings are. The score is between 0 to 100. As you can imagine, If it's very close to 100, then it's a very good match. I mean that they are very similar to each other. If it's kind of close to 0, maybe 10 or 20, and then it's a weak match. Or, if it's 0, no match at all, right? So then they are not similar. So if they are very similar, so likely they're duplicates. If they're not very similar, they're not duplicates. Okay. Quick note about this W ratio function from the RapidFast library. The syntax is really simple, just compare two strings, right? And there are actually other functions to calculate similarity. The simple ratio, like partial comparison with this library. To keep things simple, we're going to focus on this W ratio function. Well, I mean, there are many different other metrics, like simple ratio, just to compare literally how similar they are. For example, by counting how many different characters in the same position those two strings will have, right? And there's some partial order. For example, if one string is a part of the other string, they may be considered as similar. Like, sometimes we have the initials instead of the full name included in the string, right? But W ratio is really a comprehensive one that combines all those different aspects. So overall, if you don't know which one to use, and this one is usually a good choice, right? And now, just some rough rule of thumbs. So basically, if you get a score, say, above 95, it's a very good match. It's excellent match. If it's between 85 and 94, it's maybe also considered as a good match, right? And then if the score gets lower, you may want to consider that they are not so similar. Anyways, for our purpose, we just calculate the score, okay? And then it's 90.91 as the score. Is it good? Is it not good? Well, overall, I would think above 90 sounds like a very strong match, right? So that's why those two strings will be considered as the same name, because they're similar enough. It's likely a typo or other kind of issues. Now, questions for now? Hopefully this idea is clear. Okay. Now, if we want to carry on to identify all those duplications in this data set, what do? It's actually quite simple, right? Because we already know how to compare two names. And here we have a total of 9 names. All we need to do is to perform a pairwise comparison, right? So we'll compare the name in row 0 to row 1, row 0 to row 2, row 0 to row 3, and then later on we're going to compare, for example, row 3 to row 6. For every pair, we want to see how similar they are based on this RapidFuzz library to get a score. Let's say if it's about 90, which is some cutoff number you want to use. Let's say above 90, it's a good match. We consider them as very similar, so they are duplicates. If it's below 90, maybe you are going to be a bit hesitant in labeling them as duplicates, right? So that's the main idea. However, here for efficiency, we're going to do something that is somehow a preparation step, right? So what do? So I'm going to make an assumption. Looking at all those columns, let's say the nationality column and team column for all those players, let's say there's no error, okay? They are accurate. I mean, it may not be always true, but roughly, let's say there's no error. Then, if we have two players, either having different nationalities or two players playing on two different teams, then they cannot be the same person, right? Even if they have very similar names, assuming that every player can only have one nationality and serve on one team, then if any two players either sharing the same having different nationalities or having different teams, they cannot be the same person. So in those cases, as long as they don't have the same nationality or the same team, we don't have to compare them, right? I mean, this is really just something that potentially can help us with efficiency. So let's try to see how we can do this. So let me know if you have any questions so far. Okay? Now, how do we do that? There are different ways to do that, but let's actually start from defining something we call the blocking. The idea is that we're gonna, yes, please.
So basically, you're assuming that there's no typos in the team name.
Oh yeah. I mean, this may not be true, right? So that to simplify matters. I mean, also like sometimes you may have some errors in the team name as well. But then you have the typos in the team name, and also you have typos for the corresponding players. That chance is somehow usually quite real low, right? So I mean, it's no matter how hard we try to clean the data, you cannot hope for 100% accuracy. So this is somehow, at least as a demonstrating example, we can afford to tolerate. Okay. Thank you for the question. Excellent point. Yeah. So we're going to define a blocking key that contains the information of nationality and team. So then, using this team, we're going to divide people into blocks. Right? How do we divide people into blocks? Well, let's actually try to write down the code first, and then I will explain. Hopefully things will be kind of intuitive. Okay. Now, first of all, we're going to create a new column for this data frame. Right? So let's first again visualize this data frame, and that's our data frame. But I need to get a new column. But somehow it is already there. So I guess I in the clean version of dataset I actually already included. But nevertheless, assuming that we don't have this last column yet, right? And if we don't have the last column, we need to first create the last column. So let me actually do this. Okay. So we're gonna do this. So we're gonna do this. So let's say we create a new column. Here it's already there, but sorry for the mistake. So, but pretending that's not there, the last column. So we're gonna create a column called nationality team, right? And how do we do that? Well, it's gonna be the combination of the nationality column and the team column. So it's gonna be, first of all, we take the nationality column, right? And then we add it to another column, but we include a separator here. Let's say separator is underscore, okay? And then another plus sign. Plus sign on strings just means that you're combining them together. For example, if for example, if you have two strings, A and B, A plus B becomes the string of AB, right? So it's just to put things together. So, and then df teams. So it's already there, but if it's not there, it's going to create a new column for you. But here it's already there, it's gonna just be overriding what's actually here. Sorry, there's I think maybe I have a typo. It's not teams, it should be team, right? All right, so then this is to create a new column, and then let's look at it again. So basically, we created a new column that combines both information of the team and nationality, right? Now, this allows us to focus on the last column, which is something we consider as the blocking ID, which defines the blocks, right? So now intuitively, we can actually already nicely define the blocks. So let's see how we can do that. Sorry. So let me use some highlighter to show things hopefully more clearly. Okay. Okay. So for example, so record 0 and record 1 they have the same blocking ID, right? It means that they have the same nationality and also the same team. And then you can consider or label them as in the same block, right? In the same group or block. Okay. Now, and then let me use a different color. So for players number row 2 in row 2 and row 3, they also share the same block ID. So they have the same team and same nationality, and they need to be compared within the same block, right? And the 2 Maria Costas, let me use another color. They have the same block ID, so they are going to form a block. Okay? And finally, we see those 2 rows, 6 and 7, they are in the same block, right? And finally, the final record, it does not share the same blocking ID with anyone else. So the final record, number 8, will be a separate block, right? So we have divided things into different blocks, and then it will be somehow more efficient because I don't need to compare between across the blocks, right? I only need to say for those 2 blocks, for the top 2 rows in the same block, let's compare if they are similar to each other. If yes, maybe they're duplicates, right? And then for all those different blocks indicated by different colors, we only need to do the comparison within the block, right? So that's the idea. Just to be more efficient. If you want, you can just do things exhaustively. It's going to take a longer time, but it can also serve the purpose. Questions? All right, so that's the main idea, and let's move on. Now, we have the blocking ID, right? And intuitively, we can totally find out how to manually, with this small data set, we can totally manually form the blocks, right? But of course, imagine that you have a much larger data set, it won't be feasible to do things manually. So we still need to do things automatically using Python codes, right? So it's actually more generalizable. Now, what do we do here? This time, we want to perform blocking or grouping, the same concept, divide records into different blocks or groups, right? So there's a very convenient function in Python, provided by pandas to perform blocking or grouping, right? So we're going to do df, that's the name of our current data frame, right? Dot group by. So this is going to divide all those records into groups. But you need to tell the function how you would actually form the groups or blocks, right? So you just provide the name of the column based on which you would like to perform the grouping. So remember, we have this last column called nationality team. So if this column has the same value for different records, they are in the same group, right? So we group by the last column. If 2 records have the same value for this last column serving as the blocking ID, blocking key, then that's one block, right? The same block for the different records. Okay, so we can do that, and then we can run it. And after run it, let's take a pause to view actually what's there. Okay, so first of all, let's actually just use grouped, which is the name of the result. As we can see, nothing too meaningful showed up, right? Because after performing this grouping operation, what we get is simply something called the group by object. It contains all the information, but it won't show you the details. So what you can do is that we can do grouped dot groups, and then it will give you some information about the groups. Right? So as we can see, it's something like a dictionary, right? So in the first entry in this dictionary is a blocking ID, AR, Argentina Racing Club, nationality plus the team, right? And then after this semicolon, a column, we have 2 and 3, meaning that row 2, row 3, row with ID number 2 and 3, and those are inside the block that share the same blocking ID of AR and Racing Club as the nationality and the team, right? And similarly, row number 1 and row number 0, they are in a different block. They share the nationality Argentina and the team River Plate. And for the remaining blocks, it can be interpreted rather similarly. Of course, I feel that this is not that intuitive. Even though it gives the necessary information. So let's actually do something like an iteration to enumerate over all of those groups inside this group by object. Right? And then we want to be able to view all those groups more clearly. So let me delete this. Or maybe I don't delete this, but I just start a new line so that whatever is done in this line is not going to be shown. So let's do a for loop, right? So for key, let me first type the command and I'll explain. Key and group, in grouped. And then column. Okay. So basically, for this group as a group by project, there are many different groups. Each group will have a group ID, which is the same as what we call the blocking key, right? Because that's how we perform the grouping. So key is going to be the blocking ID, group is the content of the group, so we're going to enumerate over all those groups inside the group by object. Right? Now what do we do inside this? What do we do inside this for loop? First of all, we want to print out the key, but let's use an F string, okay? So because we want to provide some, descriptions inside the information we want to provide. So group key, and then this is the string, but then we want to really include the value of the key, right? So this is the blocking ID for the group we fetch, right? And then after that, let me include, \n. So \n means that we are changing to a new line. We're gonna include a change line symbol so that whatever we display next after this line of command will be on the new line. Okay. Now this is to show the key of the group I want to display, right? Within each iteration of the loop. Next, we're going to do display. Display is only for Jupyter Notebook to display the data frame in a nicer format. We're going to display group, and group is the element we're enumerating over in this for loop, right? So display group, and after that, let's print another change line symbol. You don't have to do that, but just I was hoping to, have wider gaps between those different groups so that things can be visualized more clearly. So let's see if this can work out. It worked out pretty well. So first of all, when the for loop fetched the first group, it displayed us the blocking ID or the group key, right, which is the value of the last column based on which we perform the grouping operation. And then the content of the first group, which is row 2 and row 3. Okay? And then it moves on to the second group. Group key is the Argentina River Plate, and then it has 2 records. Okay? And the third group, key and content, fourth group, key and content, and the last group. Okay? Now, things will become somehow easy at this stage, right? Because now we can focus on every single group. Every time I focus on one group or one block, I compare what's inside that group. And then let's again develop some intuition based on some manual checking. Now, the first group or first block, 2 records, if we do things manually, just look at the names, looks like they're the same person, right? Because the name, it can be 2 brothers potentially, but then we're sisters, right? So we don't really know, but potentially, but it looks like it's possibly that they are the same person. So, and then for this group, maybe we can do some deduplication by dropping one of the records, right? If you believe that they are the same person. And the second group, the two Maria Costas, most likely they're the same person, just drop one. And the third, fourth group, and we just do this for every block or every group to identify any possible duplications within each group. And that's going to be finished. Okay, so any questions? This is the intuition. Of course, we haven't done anything yet. Now, we have to put down things in Python codes, right? And how do we do that? Well, let me quickly show you, but this time we're going to keep things simple by, just to give you the main idea, because, it's not really too difficult, but rather tedious. So I already included this code. I didn't do this code. Instead, I generated with Gemini. It's not too difficult if you want to do it yourself, but it's a bit tedious. As you can see, it's relatively long. I think if we spend time in class to type all those commands, it will take a lot of time, maybe 20 minutes at least. So let's not do that. So what I did is that I simply gave some prompts to Gemini, and then Gemini generate the code for me. I'm not going to do it again because Gemini and other Gen AI tools, they are somehow probabilistic, right? So next time you run it, it will generate somehow similar but different codes. It may or may not work. You have to go back in there to identify any errors if there are any. Okay, so instead, let me move to a set of slides to explain the key idea about behind those Python codes, right? And then we just run the Gen AI based codes. So what do we have here? So we have the original data set. Here I'm just showing you a simplified example instead of the full data set, to have better focus. Okay. So let's say this is the whole data set. Okay? What do we want to do? I want to focus on what we want to do, and that's exactly how I created the prompts. I just tell Gemini what I wanted to do. Okay. So we know that all those rows, they have IDs. So row 0, row 1, row 2. Things start from 0 by default, right? And then we have n-2 for the n-first row, and n-1 for the last row. Okay, that's how the default ID works. Okay. Now, I want to create actually two more columns. One column is called canon ID, or canon for canonical. Right? What do I mean by that? So let's say we have, let's just assume that eventually name1 and name2, they will be duplications, right? So they will be treated as the same record, and we want to eventually put all the records that refers to the same person into one bin, and there will be many bins, but each bin will be duplicates of the same person. Okay, let's say 0 and 1, they're the same person. Now, they form somehow a cluster, or this is slightly different from the blocking we just performed. Let's call it cluster. A cluster of records that are pointing to the same person, right? Now, we have the cluster consisting of row 0 and row 1, right? But then we can pick a representative. Right? Either row 0 or row 1 can be the representative. You can arbitrarily decide. Let's say row 0 is the representative. So I'm going to put canonical ID for row 0 as 1, and for row 1, 0, because that's the ID of the first row, right? And then row number 1, the canonical ID is also 0, because we want this bin or cluster of duplicates represented by one of them, which is the first row number 0, right? So that's the canonical ID. And then I want to have another column, which is the matching score. This is going to be based on the fuzzy matching. So let's say name1 and name2 are really similar. Let's say eventually the match score between name1 and the representative, which is itself, is going to be 100%, right? because, you know, compare the row 0 with the representative of that cluster of duplicate records, it's the same record, same row, so it's 100%, right? Name 1 and name 1, that's the comparison. Now, row 1, which is name 2, we're going to compare that with the representative of the same cluster, which is row 0, name 1. Let's say it's 95 as the score. So this is what I want to create, so that we can visualize which rows should be thrown into the same bin of duplicate records, and how close is the match between each row with the representative of that cluster. Right? So that's the main idea. So, but of course, like we have different blocks already. So we only need to focus on one block at a time to perform this procedure. And remember, we only have 2 records in all those blocks except one block with only one record, but imagine that we have a much larger data set. Each group or each block will have many records, right? So let's focus on one group. They all share the same team and same nationality. And then I'm going to describe how this procedure works. And there may be different ways to do this, but I'm using a simple and intuitive way to perform this. Let's say we just pick the first row, first record within the block, right? And then what we can do is that we're going to compare the first record with all the remaining records. Right? Name 1 with name 2, name 1 with name 3, name 1 with name 4, and name 1 with any other names to see how similar they are. So some will be similar, some will not be similar to name 1. Right? So eventually, let's say, if we start from name 1, eventually, for example, we say name 1, name 2, and name 4, those are going to be very similar to name 1. So they are considered as the cluster of duplicate records among themselves. Okay, so that's the first step. And then after we have performed some clustering by comparing how similar name 2, 3, all the names are to name 1, we can form one cluster. But then next time we're going to jump to name 3 because 1, 2, 4, they are somehow already clustered, right? So we just find the next unclustered record, name 3. And then this time we don't touch on the already clustered names. Instead, we'll compare name 3 with all the remaining unclustered records, name 3 with name 5, name 3 with name 6 to see how similar they are, right? Turn out, let's say, actually name 3 is not very similar to the remaining unclustered names, name 5 or name 6, they're not similar, so name 3 will just be the cluster of itself. There's no duplications, for example. And then we move on to the next unclustered record, let's say name 5. So we're going to compare name 5 with name 6. Those are the remaining 2 unclustered records in this example. Want to see how similar they are. Let's say they are kind of similar, so they are thrown into the same cluster of duplicate records, right? So then we have those. This actually, the color doesn't show up very well on the screen, right? But then in this way, what we have is that name 1, 2, 3, let's say they are inside one cluster. Name 1, 2, 4, and name 3 is a cluster by itself, right? And then name 5 and 6, they are the remaining cluster. So that's how we perform cluster. And this is, of course, just some intuitive idea. And then after you have formed all those clusters, let me just mark them again. Okay. You know, the same symbol represents the same cluster. Now, we can pick any record in the same cluster to be the representative, right? So for the checkmark cluster, let's say we just use 0, which is name 1, as the canonical ID, the representative, right? And name 3 is itself is a cluster, so just the canonical record will be just itself. See? So I shouldn't use the symbol. So name 3 will be having the canonical ID as 2 because the row ID of name 3 is 2, right? And then for name 5 and name 6 in the same cluster, we can pick any one of them. Let's say we pick name 5, which is having the row ID of 4. So this is how we add a new column pick a representative that is within the same cluster after performing this kind of clustering. Okay, so so allow me just maybe 1 minute to finish the example here, and we will have a quick break. Right? So let's not go dive into details of this code. I'm going to simply run them and then explain what happens after we run them. So I think it should be finished, right? So now, whatever we have included in this code cell, what's important eventually is this new data frame produced by this cell of codes. And let me copy the name df fuzzy match, right? And then we're going to quickly move on to the next cell to view this outcome. Right? So what we have produced from that code cell is a new data frame. Let's see what's inside the new data frame. Essentially the same as before, but the difference is that we have two additional columns, right? Canonical ID and match score. And let me quickly finish this, and then we can start the break. So just a quick demonstration. Okay. Now, quick demonstration. So for example, let's look at row number 0, and the canonical ID value is 0. So, the representative of the same cluster is just itself, right? But then for row number 1, it's also considered as the representative itself. So to be on the cautious side, we're not actually put those two in the same cluster, right? And then if we look at, for example, Maria Costa, row number 4 is actually the representative of the cluster, right? But row number 5, it's in the same cluster. The representative is also row number 4, right? So there are different rows, but the representative is actually the same record, which is row number 4. So they're in the same cluster. Okay, and then for row number 6 and 7, Anna Martin, they are considered to be similar, and then the representative of those two records will be record or row number 6. Okay, so that's some clustering, and then finally, the last step before the break. Let's do this. Here is the link to the slides I just showed you. Right? Finally, we want to drop all those duplicated records. Right? So how do we do that? Actually, if you look closely, right? So, for example, for Maria Costa, row number 4 and 5, only one of them needs to be kept, right? And then turn out for row number 5, because it is already represented by the representative canonical record, which is row number 4, it can be dropped, right? So the observation is that if the row ID is actually equal to the representative, and then it's representing itself, so we keep it, right? If the row ID is different from the canonical ID, it means that it's represented by someone else, so we can drop that record. Okay, so very quickly, let me finish this set of this notebook by this command. So we're going to create something based on df fuzzy match. We're going to do some filtering. Okay, so what we're going to filter. How we perform filters provide a condition, right? So we only want to pick some of the records, but what is the condition? Well, it's going to be an equality check. Okay, so first of all, we take this data frame. So the name is a bit long, but we're going to take the canonical ID. That's the representative for that record, right? If it's the same as df, same data frame, okay? But then we take the index of that row. If the index is equal to the canonical ID, that record is the representative. We keep it. If it's different, I mean that record is actually represented by someone else. So we can drop that record because it is considered as a duplicate. Right? So let's just perform this. And then, as we can see, if you look at the row indexes, it's no longer continuous. Right? Some of the row in the original data frame is actually missing, and then we only kept all those representatives of the corresponding clusters that contain duplicate records.